Hello learners, on behalf of Indira Gandhi National Open University, myself Subhasis Maji, Professor in Mechanical Engineering of School of Engineering and Technology, welcoming you for this interactive lecture session. So today's topic is Introduction to Temperature and Heat. This is the fourth module of the course Thermodynamics and its Applications. In our earlier classes, we have discussed in detail energy and energy transfer. So today's topic is Introduction to Temperature and Heat. These are all relevant to our day-to-day life. After listening to this video lecture, you will be able to understand the concept of thermal equilibrium, state and explain the significance of zeroth law of thermodynamics. You will be able to recognize inequality of temperature. You will be able to explain the principle of the ideal gas thermometer, and also you will be able to identify the three modes of heat transfer. Now let us begin our discussion with the zeroth law of thermodynamics. Two systems which are equal in temperature to a third system are equal in temperature to each other. You see the diagram that A and B are the two systems separated by a adiabatic wall. The adiabatic wall means the heat will not be able to transfer from system A to B. But the system A and B are also separated by a system C with a diathermic wall. The diathermic wall allows heat to transfer. So from this diagram you see that there may be a heat transfer between A and C, there may be a heat transfer between B and C. Now if A and B are the two systems, if they are thermal equilibrium with a third system C, then A and B will also be thermal equilibrium with each other. So this is a very important law, we call it zeroth law of thermodynamics. This law is the basis for the measurement of temperature. Thermal equilibrium. Just now we have discussed the zeroth law of thermodynamics. Now let us see what do we mean, what is the significance of thermal equilibrium. The definition and measurement of temperature must be logically preceded by the concept of thermal equilibrium and the zeroth law of thermodynamics. Inequality of temperature in a different type of situation if system C is in thermal equilibrium with A, but when it is brought into contact with another system B, observable changes takes place in C. Then the temperature of A and B are said to be unequal. Now let us see what is the significance of measurement of temperature. Temperature is one of the most important thermodynamic properties, and its measurement and control are important in many applications in industry, research and development, commerce and home. So nowadays you might have seen at different airports or any mall, when you are entering into that mall or any place, your temperature will be measured because of the COVID-19 cases are going on. Temperature. The zeroth law now assures us that if we place a thermometer or other temperature sensors in thermal equilibrium with a body or system A, and we similarly place the sensor in a thermal equilibrium with system B, Then system A and B are at the same temperature if the sensor reads the same temperature in both cases. The two scales most useful in thermodynamics are called absolute scales. The absolute scale for SI is the Kelvin scale, named after William Thomson, who became Lord Kelvin. This scale is 1-point scale based on the second law of thermodynamics. In fact, we will introduce the first law and second law of thermodynamics in our subsequent classes. The Kelvin scale, the single point is the triple point of water, where ice, liquid water and water vapor coexist in a closed system in the absence of air. Note that the Kelvin unit does not use the degree symbol, but simply the symbol K, capital K. The other absolute scale is called Rankine scale. It is related to the Kelvin scale by T Rankine scale is equal to 1.8 T Kelvin, where degree Rankine is denoted by degree R. Fahrenheit scale. The Fahrenheit scale is also linear, and it was originally based on two defined points, 32 degree as the temperature at which a system of air saturated. The Fahrenheit scale is also linear, and it was originally based on two defined points, 32 degree as the temperature at which a system of air, saturated water and ice point coexist, and 212 degree as the temperature of a system containing water and steam at a pressure of 1 atmospheric pressure. This original definition has been replaced by the following relations to the Kelvin scale. So T degree centigrade is equal to T Kelvin minus 273.15, and T degree Fahrenheit is equal to 1.8 T degree centigrade plus 32. So we can convert from one scale of temperature to the other scale of temperature. The Rankine scale, the other absolute scale, is called the Rankine scale. It is related to the Kelvin scale by T degree Rankine is equal to 1.8 T Kelvin. Now here there are four temperature scales are shown. One is Celsius, that is centigrade. Second one is Fahrenheit. Third one is Kelvin, and fourth one is Rankine. So the Celsius scale, the ice point is at 0 degree centigrade and the steam point is 100 degree centigrade. For Fahrenheit, so ice point is 32 degree Fahrenheit and the steam point is 212 degree Fahrenheit. But for Kelvin scale, the ice point is 273 Kelvin and for the steam point is 373 Kelvin. Now we will discuss about ideal gas thermometer. The ideal gas thermometer consists of a glass bulb connected to a U-tube containing a liquid such as, for example, mercury. A permanent gas, example oxygen, nitrogen, hydrogen, is enclosed within the bulb and the connecting flexible tube by the mercury on the other limb of the U-tube open to the atmosphere. During the experiment, the level of the mercury can be adjusted to keep the volume or the pressure of the gas constant. Now you see the constant volume gas thermometer. So here we are discussing about the constant volume gas thermometer. That means the gas which is there in the bulb is always kept constant for this process for measuring different temperatures. So here the bulb is immersed in a liquid bath or environment to be measured, and there is a flexible tube and mercury reservoirs and there is a scale. Now for this thermometer we will always keep the volume of the gas constant by manipulating the flexible tube. Operation of a constant volume thermometer. Let us consider its operation at a constant volume gas thermometer. In order to set up temperature scale, we note the difference in the right hand meniscus, indicative of the gas pressure at the two fixed points, maintaining the mercury level in the left hand lip and hence the gas volume. Constant in each case. A gas thermometer Celsius scale is defined by assigning 0 and 100 to the ice and steam points with 100 equal subdivisions between them. The linear scale gas pressure P may be expressed as P is equal to Pi within bracket 1 plus alpha T, where Pi is the gas pressure at ice point at 0 degree centigrade and T the gas thermometer Celsius temperature. Alpha is a constant equal to alpha is equal to Ps minus Pi divided by 100 Pi, where Ps is the gas pressure at the steam point at 100 degrees centigrade. Now let us talk about the heat. Heat is the interaction between systems which occurs by virtue of their temperature difference when they communicate. There are two important parameters that are absolutely necessary for heat transfer. One is temperature difference, second one is communication. Now, if there is a system and if there is heat loss, by sign convention, as per sign convention, it is taken as negative, and heat gain by the system is taken as positive. Now, if you keep a hot cup of coffee in the table, and you will see that the coffee is getting cooled. The reason behind this that there is a temperature difference between hot coffee and the environment or that atmosphere. So hot coffee's temperature is much higher than the outside temperature or room temperature. So definitely heat will be transferred from hot coffee to the environment, and after some time both will be equilibrium conditions. And communications, it is also very important. Heat is defined as a form of energy that is transferred across a boundary by virtue of a temperature difference. There are three modes of heat transfer: conduction, convection, and radiation. Now, this is a very good example where you can see that three modes of heat transfer is going on simultaneously. Suppose there is a fireplace and you are holding a metallic rod and touching the fire on the other end, and definitely you will feel hot at the point where you are holding the metallic rod, and this is due to the heat transfer due to the conduction process. Now, if you put your hand a little bit higher up, then that transfer, you will feel hot, and this heat is being transferred because of convection, because the air which is nearer to the fire is heated and the density decreases, and because of the less density it is moving in the upward directions and it will carry heat, and that's why you will feel hot. In the third mode of heat transfer, that is radiation, even after a long distance you will feel hot, and that is the heat transfer due to the radiations. So there are three modes of heat transfer: conduction, convection, and radiation. And for a solid, generally heat transfer takes place due to the conduction, and for liquid and gas or air, the mode of heat transfer due to the convection. But we are getting the heat energy from sun due to the radiation. Now, this is another example of the mode of heat transfer that radiation, we are getting energy, heat energy from sun, and that is due to the mode of radiation, heat transfer due to the mode of radiation. And convection, because the air which is in contact with the surface, that is also getting heated, and the density of the air decreases, so it is going up in the directions, that is due to the convection. But on the surface of the earth, if you keep any object, that will also be heated, and that is due to the heat transfer due to the conduction. Now the air which is very near to the surface of the earth, that is also being heated because of conduction. A final comment on temperature measurement. Temperature is one of the most common and important properties measured by engineers. It is important to note that how to measure the temperatures. It is important to note that thermometers really measures only its own temperature. It is up to the engineer to ensure that the thermometer is at the same temperature as the system whose temperature is desired. And temperature is one of the most important property in thermodynamics, and later on you will see that there are several other properties depends on the temperature. When you talk about the internal energy, that is a function of temperature. If temperature increases, the internal energy of substance will also increase. Now let us discuss some important numericals. Two thermometers, one reading in degree centigrade and the other in Kelvin, are in thermal equilibrium with the same system. What is the temperature of the system if both thermometers have the same numerical value? So it is a very interesting numerical, and let us see how we can solve. That we know the relations between degree Celsius and Kelvin. So Tk is equal to Tc plus 273.15, and it is given as Tk is equal to Tc. So Tc is the temperature measured in Celsius scale and Tk is in the Kelvin scale. Now it is clear that this cannot occur at positive values on the Celsius scale, because if Tc is positive, so since it is plus Tk, capital Tk is equal to Tc plus 273.15. So if Tc is positive, so we can, this equation will not give you the correct answer for the problem which is given. It is clear that this cannot occur at positive values on the Celsius scale. With negative values on the Celsius scale, if you put Tk is equal to minus Tc plus 273.15, then put the value Tk is equal to Tc and calculate the value of Tc, that is equal to 136.575 degree centigrade or Kelvin, and that is the numerical value for which both will give you the same results. Now let us discuss about the next example. The readings T1 and T2 of two Celsius temperature agree at the ice point and at the steam point. They are related by the equations T1 is equal to A plus B T2 plus C T2 square between these 2 points where A, B, C are constant. When both are immersed in an oil bath, T1 is 51 degree centigrade while T2 is equal to 50 degree centigrade. Determine the value of T1 when T2 reads 25 degree centigrade. Now you see that the expression of T1 is given as A plus B. T1 is equal to A plus B T2 plus C T2 square. So both the scales agreeing with the ice point as well as the steam point. Now ice point is 0 degree centigrade and steam point is 100 degree centigrade. So if you put the values of T1 is equal to 0 and values of T2 is equal to 100, so we will get two equations and two unknown. But one more equations we will get while putting the T1 equal to 51 and T2 is equal to 50. At the ice point, when T1 is equal to 0 and T2 is equal to 0, the equation A will be 0, because A, if you see the first equations for the expressions of T1 and put the value of T1 and T2 both equal to 0, then obviously you will get A is equal to 0. So first constant we have got A is equal to 0. Now at steam point, when the T1 or T2 is equal to 100, if you put 100, T1 is equal to 100 and T2 is also is equal to 100, then the equations you will get 100 is equal to 100B plus 100 square C. So when T1 is equal to 51 and T2 is equal to 50, put these two values, you will get another equations, that is 51 is equal to 50B plus 2500C. Now you see the equations 1 and 2, there are two unknowns B and C and there are two equations. So we can solve these two equations and find out the value of B and C. If you solve these two equations, the value of B will comes out to be 1.04 and C is equal to minus 0.4 into 10 to the power minus 3. So the expression of T1 you will get as A plus B, T1 is equal to A plus B T2 plus C T2 square. So if you put the value of A, B and C and for T2 is equal to 25 degree centigrade, you can easily calculate the value of T1 equal to 25.75 degree centigrade. Now this is another very good numericals, and let us see how we can proceed for this numerical. A temperature scale of certain thermometer is given by the relation T is equal to A ln P plus B, where A and B are constant and P is the thermometric properties of the fluid in the thermometer. If at the ice point and steam point the thermometric properties are found to be 1.5 and 7.5 respectively, what will be the temperature corresponding to the thermometric property of 3.5 on Celsius scale. Now in these equations, that T is given as A ln P plus B. A and B are constant, but P is the thermometric properties. Now see, ice point, that means T is equal to 0 and the steam point means T is equal to 100. So if you put the value of T as 0 or equal to 100, so we will get two equations, and with the help of two equations we can easily find out the constant A and B. After that, once you get the values of A and B, then we can put the value of A and B and we can get an expression for T only in terms of the thermometric properties P. So any property, if you get the final expression for T in terms of P only, then you can get the value of T by putting P is equal to 3.5. Now let us see, in this equations it is given as T is equal to A ln P plus B, and at ice point T is equal to 0, at steam point T is equal to 100. So if you put T is equal to 0, the one equation will be 0 plus A ln 1.5 plus B, and if you put T is equal to 0 again, and for thermometric properties P is equal to 7.5, the next equation will be 100 equal to A ln 7.5 plus B. Now here there are two equations. The first equation is 0 is equal to A ln 1.5 plus B, and the second equation is 100 is equal to A ln, that is ln is natural logarithmic, so ln 7.5 plus B. So two equations, two unknown. We can just solve these equations for finding out the values of A and B, the constants of A and B. And then if you solve these two equations, you will get the value of A is equal to 62.112 and B is equal to minus 25.18. Now for calculating T for P is equal to 3.5, how to get it? Once you get the values of A and B, now put the values of A and B in the main equations. So main equation comes out to be T is equal to 62.112 ln P minus 25.18. Just put the value of P, that is 3.5, and finally you can get the T is equal to 52.63 degrees centigrade. So in this way we can solve these problems. Now there is a very interesting example we have taken up, how to calculate the temperature. A constant volume gas thermometer containing helium gas, reading of gas pressure P of 1000 and 1366 millimeter of Hg at the ice point and steam point respectively. So at 0 degree centigrade, the gas pressure is calculated as 1000 millimeter of Hg, and for ice point, steam point, that is at 100 degree centigrade, the gas pressure is calculated as 1366 millimeter of Hg. Express the gas thermometer Celsius temperature T in terms of the gas pressure P. And second part of this problem is, if the thermometer reads 1080 millimeter of Hg, determine the corresponding temperature. Now this is a constant volume gas thermometer. So we have already discussed that for any measurement of temperature we have to manipulate the hose pipes or the vertical cylinder which is for holding the mercury in such a way that the gas inside the system will be always constant. That's why it's known as the constant volume gas thermometer. Now let us see how we can tackle this problem. So for a constant volume gas thermometer, we know that the pressure P is equal to Pi within bracket 1 plus alpha T, where Pi is the pressure at the ice point, and here the alpha is a constant that is equal to Ps minus Pt, Ps minus Pi whole divided by 100 Pi, and Ps is the pressure at the steam point, Pi is the pressure measured by the mercury level, that is Pi is the pressure at the ice point, and Ps is the pressure at the steam point. And for this problem, the pressure measured at ice point as well as the steam point are given. So alpha we can calculate, that is 1366, that is the pressure at the steam point, and minus 1000, that is pressure at the ice point, whole divided by 100 into 1000, because 1000 is the value of pressure at ice point, and that comes out to be 3.66 into 10 to the power minus 3. So the constant value, the value of the constant we have already calculated, and the final expressions for P is equal to Pi within bracket 1 plus 3.66 into 10 to the power minus 3 into T. So here this is the expression relating to pressure and temperature. So initial the pressure at ice point Pi is known, that is 1000 millimeter of Hg, but we have to calculate the temperature for the pressure 1080 millimeter of Hg. So the Pressure P is given as 1080 millimeter of Hg, and Pi is the pressure at the ice point is also given as 1000 millimeter of Hg. Put the value of these two pressures in these expressions for the temperature equations, and we can after little algebra you can get the final result for temperature is equal to 21.86 degrees centigrade. Now in this lecture we have introduced the temperature and heat. Both are equally important for thermodynamics and for analysis of any problems like vapor power cycle, a refrigeration cycle, a gas power cycle. So the knowledge of this heat transfer and how the temperature behaves for a gas, for constant pressure process and polytropic process, and if there is a compression or expansion for gases, how they are related, these are extremely important, so that we have to have a clear-cut knowledge for this temperature. And the heat is also very much important because heat and work are intimately related with energy, and the thermodynamics is a science which deals with heat, work and energy. Now in the next class we will discuss about the properties of pure substances, and there we will see that there are phase changes takes place for, say for example, ice. If you supply heat, what will happen? Ice will melt. If the ice temperature is 0 degree centigrade, then even if you supply heat, the ice will melt, but till it melts, total full amount of ice, the temperature will remain constant. Because why the temperature remains constant even though if you supply heat to the ice? Because here the change of phase takes place. Now when it is totally converted into water, if you supply heat, the temperature of water will increase from 0 degree to higher degree like 10 degree, 20 degree and go on, and you will see that even if you keep on supplying heat, the temperature will increase, and when it will increase 100 degrees centigrade, then after that you will notice that even if you supply more heat, then it will be transforming into vapor, but temperature will remain constant. Now again there is a phase change takes place, and because the water will be converting into steam, and till all the water converts into steam, the temperature will remain constant because there is a change of phase takes place. And in the next class we will see how the change of phase takes place and how we can get the pressure volume and diagrams, and that will be very, very important for analyzing Rankine cycle or any problems relating to that vapor power cycle or refrigeration cycle. Because in the refrigeration you will find that when it is circulating in the cycle, sometimes it is converting into vapor, sometimes it is converting again to liquid and so on, and those are very interesting problems. But to understand those difficult topics, we must have clear knowledge of the thermodynamic properties like pressure, volume, temperature, internal energy, enthalpy. So my dear students, so today we have discussed about temperature and heat, and let us summarize our discussions. We have discussed today the concept of thermal equilibrium. We have discussed the significance of zeroth law of thermodynamics. We have discussed the inequality of temperature and the principle of ideal gas thermometer, and the three modes of heat transfer, that's conduction, convection and radiation. And we have also solved some problems related to thermometer. So thank you very much, and in the next class we will discuss about the properties of pure substances. Thank you very much.